Hello dear students, let us see in this session file organization of records in a file. Okay. What does file organization mean? The database is stored as a collection of files. Each file is a sequence of records. The record is a sequence of fields. Here is one approach. Assume record size is fixed. And each file has record of one particular type only, and different files are used for a different relation. This case is easiest to implement. We'll consider variable length records later. Okay, fixed length record, simple approach, stored a record I starting from the from bytes like n into I minus 1, where n is the size of record. Record access is simple, but records may cross blocks. Modification do not allow the records to cross block boundaries. And deletion of record I. Alternatively, move the record I plus 1 on n and to I n minus 1, I to the n minus 1. Move the record n to I and do not move the record, but link all the free record on a free list. Okay, so this is the case. Here is one example. There are 11 records we are having. Then among this, deleting 3 records. If you are computing the 3 record delete, then if you delete 3 records according to the algorithm, move n minus 1 disk. So move n minus 1 disk in the sense 11th disk has to be moved. Okay, see here, 11th disk has to be moved over here. Then free list stores the address of the first deleted record in the file header and uses this first record to store the addresses of the second deleted record and so on. That can think of these stored addresses as a pointer, since they point to the location of the record. More space efficient representation and reuses the space for a normal attribute for free record to store the pointers. No pointer are stored in case of records. If you consider that one, then they will be replaced and they can have as a free places can be moved over there. Then variable length record. Variable length records arises in the database system in several ways. Storage of multiple record types in a file and record types that allows variable length for one or more fields such as a string, and record type that allows repeating fields used some of the older data models. And attributes are stored in order. Variable length attribute represented by fixed size, offset and length if you consider both, with the actual data stored after all fixed length attributes. Null value is represented by null value bitmaps only. So for example, I have shown in the example, that is a null bits. Null bit is represented and stored in a 1 byte. In between that your data symbol. Then variable length record, slotted page structure, that is a size, location and block header and records. End of this free space one. Slotted page header contains number of records entries, end of the free space in a block, location and size of each record. Records can be moved around within the page to keep them contiguous with no empty space between them. An entry in the header must be updated. Pointers should not point directly to the record. Instead of this, they should point to the entry of record in a header. And organization of records in files, if you consider, then heap. A record can be placed anywhere in a file where there is a space. Sequential stores records in a sequential order based on the value of each type of record. Hashing, a hashed function computed on some attributes of each record. The result specifies in which block of filed record should be placed. Records for each relation may be stored in a separate file. In a multiple clustering file organization, records of several different relations can be stored in a same file. Its motivation is store the related records on same block to minimize the I/O. The sequential file organization, if you consider, then the records will be stored in a sequential and suitable for applications that require the sequential processing entire file. The records files are ordered with a search key. Okay, and deletion, if you consider, then use pointer change to delete that. So for example, we are seeing an example. Insertion at a particular location, then position where the record is to be inserted. If there is a free space, insert there. If there is no space, insert the record in an overflow block. In either cases, pointer chain must be updated. Need a recognize of a file from time to time to restore the order. For example, you can see here. See, after this one we have to insert this. Okay, but it is full. So what they are doing? They are doing in a buffer. They store in a read buffer. But what they are maintaining? They are maintaining its pointer. After that, the data has to point to this block and again back to the here. It has to flow. This way you need to maintain the sequence. Multi-table clustering file organization. Store the several relations in a one file using a multi-table clustering file organizations. Here for example, we are having a department as one and instructor as another table. Multi-table clustering means department and instructor together. We have selected some of the information from that. That is a computer science we had, and physics western we had, but we had a IDs also. Okay, that needs a multiple clustering file organization. Here is a bit for queries involving the department and instructor, that join tables instruction, and for queries involving one single department and its instructors. Bad for queries involving only department. Results in a variable size record can add pointer chain to link records of particular relations. Okay. And data dictionary storage, if you consider, then data dictionary is also called as a system catalog and it stores the metadata. Metadata andre how many number of columns it is having, name of the column, type of the column, and constraint of the attributes, particular attributes constraints ಏನಿರುತ್ತೆ ಅಂತ. So that it is called as the metadata. The data about the data is such as information about relation, name of the relation, name, type, length, attribute each relation, name and definition of views, integrity constraint, user and accounting information including a password, statistical and descriptive data, number of tuples in each relation, and physical file organization information, that is how relation is stored, and physical location of the relation information also. This has been there in the lecture note also. The metadata, how does it contains the relationship between them, relation representation on a disk, and specialized data structure, designing for the efficient access in the memory. So how does it is going to be? Index name ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ ರಿಲೇಷನಲ್ ಮೆಟಾಡೇಟಾಗೆ ಎಕ್ಸೆಸ್ ಆಗುತ್ತೆ, and attribute metadata accessed, and user data also can be accessed to content. Then storage access. A database file is partitioned into fixed length storage units called blocks, and blocks are units of both storage collection, allocation, and data transfer. Database system seeks, database system seeks to minimize the number of block transfer between, seeks to minimize the block transfer between disk and memory, and we can reduce the number of access by keeping as many as blocks as possible in the memory. Buffer is a portion of the main memory available to store copies of disk blocks, and buffer manager is a subsystem of responsible for allocating a buffer space in a main memory. Okay. So thank you for watching this video.